Yeah, all right. Well, you tell Sal Khan I've had enough. Okay? Tell him to stop contacting me. I know he wants my videos because he needs a template for success. But I've had enough. All right. About time we do this video. Ooh. Oh. Hi. I didn't realize that I already pressed go. Pressed the red button. Or pressed. I'm not doing this video again. I'm not. Okay. Graphing linear inequalities. Hi. Okay. So let's start out with graphing a linear inequality. Okay. So let's say that I've got y is greater than or equal to 1/2 x plus 3. Okay. We're going to graph this just like we graph a normal line. Okay. The y-intercept is plus 3, which means I'm going to go up 3 on the y-axis and make a dot. The slope is 1/2, meaning up 1, right 2. Rise over run. Up 1, right 2. Let's do that a couple more times just to make sure that we get the gist of it. Now, the part where graphing linear inequalities is different than graphing linear equations is right here for the inequality part. This is a greater than or equal to sign. Because there is a line underneath here, that little line that indicates equal to, this is going to be a solid, complete line, like a consistent, solid line, right? And the part where the shading comes into whether it's a greater than sign or a less than sign. This is a greater than sign, which means I am going to shade above the line. Now, this will come in handy a little bit later on when we do graphing systems of inequalities or systems of linear inequalities. I like to just make a couple of little tick marks going above. Now, really, for this exercise, that's not important, nor is it necessary. But I like to do that because, again, like I said, that's going to be important later on for us when we go to the next step. So just go ahead and start getting in the habit of doing it. And then I'm going to shade everything above. Now, what does that mean? It means that every single possible infinite point is a solution to this inequality, right? Even points that are on the line represents a solution to the inequality. So let me explain what that means. We already know that 0, 3 is on that line because we use that for graphing. So let's try to mess with that a little bit. 0, 3 is an XY coordinate pair. Let me plug in those values to the inequality and let's see what that gives us. So 3 is y is greater than or equal to 1/2 times 0 plus 3, right? Or times 0 plus 3. So when I simplify this thing, I get 3 is greater than or equal to 3 because the 0 and the 1/2 cancel out. And we got to ask ourselves, is that a true statement? Well, it certainly is because 3 is greater than or equal to 3. Now, why did I do that? Well, because I want to indicate or help you understand what happens when there is a point that's on that line. So if there's a point on a solid line, that also can be a potential answer or an answer for the inequality, right? Let's go ahead and do a different one. And we'll make it like a less than sign so we can see a little bit of a difference. So let's go with y is less than, I don't know, -3/4x plus 5, okay? So again, we're gonna graph it like it is a regular equation, plus 5 on the y-axis, 1, 2, 3, 4, 5. Down 3, right 4. 1, 2, 3, 1, 2, 3, 4. Again, I'm gonna do that 1 or 2 more times so we can see the whole kind of line. Down 3, right, 1, 2, 3, 4. Down 3, 1, 2, 3, 4. Okay. Now, clearly, like we talked about a little bit in class the other day, there is no line underneath here, which means we are going to make a dashed line. A lot of kids will draw a solid line and then kind of erase little parts of it. That's fine too, but know that it's dashed. And I'm going to explain the reason for that in a second. This is also a less than symbol, which means I'm going to be shading below the line. Okay, so sometimes it gets a little crazy about, well, where is above and below when it's a really steep line? Just draw arrows going either down or up, and that will help you too, kind of indicate where we're going to make our stuff. So then I'm going to shade everything down here, and that will be part of my answer. Okay, now let's go back to this thing we talked about before with if there was a point on this line. Well, since this is just less than, a point that's on a dashed line is not a part of the solution set. So let's go ahead and do an example. We know 0, 5 is the y-intercept, and it is a part of how we created this line. It is also on that line. So let's use our xy pair and plug it in and see what we get. That's a terrible way. 5 is less than -3/4x plus 5. Okay, well, I'm going to replace that with a 0, and I'm going to cancel those out. So then we ask ourselves the question, is 5 less than 5? No, 5 is not less than 5. which means that there is a reason, a specific mathematical reason why this is dashed to indicate to us, to help us understand that points that are on that line are not potential solutions. This was a 5-minute video. That seems excessive.